Now we're going to look at the family of functions. If a, h, and k are real numbers, a not being equal to 0, then the graph of y equals a times f of x minus h plus k is a transformation of the function y equals f of x. All the transformations of a function form a family of functions. For example, any function of the form a times x minus h, the quantity squared, plus k is in the square or quadratic family because it's the transformation of y equals x squared. The graph of any function in the square or quadratic family is called a parabola. Now we're going to start looking at transformations of graphs. We have graph here already, the basic function f of x equals the absolute value. So you'll recognize that v function. We're going to find out when instead of just a plain f of absolute value of x, it's the absolute value of x minus 4. So when x is negative 2, negative 2 minus 4 will be negative 6. Absolute value is 6. 0 minus 4 will be negative 4. Absolute value is 4. 2 minus 4 will be negative 2. Absolute value is 2. 4 minus 4 is 0. Absolute value is 0. 6 minus 4 is 2. Absolute value is 2. So we're going to graph these points. Negative 2, 6, 2, 4, 6. That's going to put it about right there. 0, 4. 6 may be a little low. 2, 2. 4, 0. And 6, 2. What my 6 was low. Okay. Notice that it's still that same v, it's just moved over 4 places. The subtracting 4 from the x moved it 4 to the right. And this slide will show us what happens. Notice if the basic function is this blue one, when we subtracted 3 from the function, it moved it 3 places to the right. When we added 2 to the x before we found it, it moved it 2 places to the left. So adding to the x moves it to the left. Subtracting from the x moves it to the right. Now you'll notice on this one, we're still subtracting 4, but we're doing it after the absolute value. And when it's not directly connected with the x, let's see what happens. So here we have the absolute value graph already. If we do it, if we take the absolute value and then subtract 4, we'll get 0, negative 3, negative 4, negative 3, and 0. Let's look at that. Negative 4, 0. Negative 1, negative 3. Negative 0, negative 4. 1, negative 3. 4, 0. Is still that v, except now it moved it down. So after we did the absolute value, this moved it down 4. And here we have a slide to help us with that. If it's take the basic function and add after it, it moves it up and down. Adding moves it up, subtracting moves it down. Now here's a summary of that. Notice when the h is added directly, and this is h and k and a are all positive here. When the h is added or subtracted directly to the x, Before you do the function, it moves it left and right. When you've done the function and then you just add this number, add or subtract this number, then it moves it up or down. And if you have a negative, if you take the function and you take the negative of the whole function, it basically flips it down. So if we had this up here, we flipping it down, it would be like this. Okay? If you change to a negative x, then it reflects it across the y-axis. So if that was the y-axis, we had it here. The new one would be over here. Now here we have the basic function is f of x, and that's the one that's graphed here in blue. But what will adding 3 do to it? Well, it will move it up. So it'll move this point up 3 spaces. It'll move this point up 3 spaces. This point up 3 spaces. Up 3 spaces, up 3 spaces. It will look like this. Up 3 spaces, up 3 spaces, up 3 spaces. Moves the whole thing up 3 spaces. This one, notice we're adding it directly to the x. Before we do the function, we add it to the x. Okay, what will happen there? Let's find out. Okay, well, a 3, I think our notes say, that moves it. Adding 3 will move it 3 to the left. So 3 to the left, 1, 2, 3 to the left, 1, 2, 3 to the left, 3 to the left, 3 to the left. Let's see what happens when we actually do that. This is what it turns out looking like it when we've moved it 3 to the left. This one, what's going to happen? This minus 2 with the x, that's going to be 2 right. And this plus 3 means 3 up. So if I get from this point, go 2 right and 3 up. From this point, go 2 right and 3 up. From this point, go 2 right and 3 up. From this point, go 2 right and 3 up. From this last point, go 2 right and 3 up. And my graph will end up being like that. Let's do that. We've gone 2 right and 3 up. 2 right and 3 up.